Exercise 9b, analysing reducing balance loans with recurrence relations. A reducing balance loan is when you borrow money but pay it back in instalments rather than at the very end. A reducing balance loan is structured in a very similar way to all of our other forms of compound interest and reducing balance. The recurrence relation will look something like this. Vn plus 1 equals R times Vn minus D. V0 is the principal, that's the original amount that we borrowed. D is the regular payment that we are paying back our loan. R is the compound interest fee, which is calculated by doing 1 plus little r over 100, where little r is the interest rate. And the way that we use it is we take the yearly interest rate, sometimes known as the nominal interest rate, and divide it by the number of compounds that are required. For example, if the question suggests that the compounding is occurring monthly, then we need to divide that rate by 12. If it's saying that it's dividing it by, or we need to divide it into quarters, or we need to divide it by 4, so it's a quarterly compounding. If it's a compounding weekly, then we'll need to divide it by 52. Example 9b.1. Charlotte borrows $2,500 at an interest rate of 15% per annum, compounding monthly. She will repay the loan by making 8 monthly payments of $330.33. Construct a recurrence relation to model this loan. So we need all of the different parts of this. So one of the ways that it's really important to break these sorts of questions, which are very big and chunky, is knowing what all the numbers mean. Firstly, there's that $2,500. That is going to be the V0. Then we've got that 15% per annum compounding monthly. So that's going to be the little r. So but you notice there it says compounding monthly, so we'll need to go and change the little r. So little r will be 15 divided by 12. We'll worry about dividing that later when we put it in the calculator, because I don't want to be risking doing any rounding too early. Remember, when you're doing any calculations, you save all of the rounding till the very last moment. She will repay the loan by making 8 monthly payments of $330.33. So there is our D value. So now it's just a matter of constructing the recurrence relation. So V0 is equal to 2,500. You don't need to put the symbols in. Vn plus 1 will be equal to, now remember, R is equal to 1 plus 15 over, let's just be 15 over 12 over 100 times by Vn minus 330.33. So all we need to do now is to find out what that is equal to in our calculator. So 15 divided by 12 divided by 100 plus 1, and we have got our value for R. R is 1.0125. Vn minus 330.33. B. Calculate recursively the balance of the loan after each payment. So this will require using the sequences option. We could do this by hand, of course. However, time is of the essence. So we shall let the CAS generate the sequence for us. So here we are, we have now got I've entered the sequence or the recurrence relation into the sequences option, and now all I need to do is I just need to go and write down the values. Now it says there that the making 8 monthly payments. So we're going to write what these are. So calculate recursively the balance of the loan after each payment. So the after payment number 1, the value of the loan is now $2,292. The second one here is worth $1,898.10. Now, I like to reiterate, it's very important to check the unrounded figure, otherwise you could be writing an entirely inaccurate sum. C. Is the loan fully paid out after 8 months? If not, how much will the last payment have to be to ensure that the loan is fully paid after 8 payments? V8, so that's telling me that the loan has 2 cents left. So all we need to do is take the payment, add 2 cents, so the final payment has to be $330.35. So I better answer the question, is the loan fully repaid? No. The payment has to be $330.35. An amortising loan is a form of reducing balancing loan. Part of the repayment goes towards paying off the interest fee that's being compounded, the other part to the original principal that was borrowed. So what does that mean? Your loan is constantly having an interest fee put onto it. So when you do your repayments, you're not only having to pay back the original amount that you borrowed, but also dedicating some of that payment to paying off the interest fee. So one of the ways that we can actually visualize this is using an amortising table. So below what I have this table of Charlotte's loan from example 9b.1, and what we're going to do is we're going to put it in an amortisation table. So how do we read it? We look at that top row here. The 0 on this left here, that's the payment number. So initially she hasn't made any payments yet. So therefore she hasn't paid anything in the payment amount. And in the interest paid, well, she hasn't paid anything because we haven't even started the loan yet. And certainly we have not getting anything taken off the principal reduction. But we do definitely have a balance of the loan initially from day one that she's been given this from the bank, and it's $2,500. So now what we're going to do is we're now going to set the next line in the table. So we agreed that it's going to be $330.33. The interest paid will be taking the interest, the calculation, the interest rate, and multiplying it by the previous balance of the loan. So in this case, we've got 15 over 12, because remember it's compounding monthly from before. Divide it by 100, times it by $2,500, and that is going to be equal to $31.25. What we're now going to find out is how much from the balance of the loan are we actually eliminating. So what we do is we take this amount, this interest, and what we do is we subtract it from the payment. And this is going to be equal to $299.08. So what does that $299.08 mean? That's how much of the money is being dedicated, that monthly repayment. So, I'm paying $330.33 each month. That's how much money is being dedicated to purely paying off the loan. The rest of that $330 that we've got there is, so the $31.25, that's purely taken up by paying off the interest fee. So this $299.08 is dedicated purely to taking off the balance of the loan. So to find out what the new balance of the loan is, we take that $2,500 or the previous balance of the loan, and we subtract $299.08, and we get $2,200.92. So then we've got payment number 2 to worry about. So again, we've got this regular repayment. And again, we're going to do the same calculation, that 15 over 12 over 100. But instead of times 2,500, we take the previous balance of the loan. So we always multiply with the previous balance of the loan. And in this case, the previous balance of the loan is $2,200.92. And so when we multiply that together, should equal to $27.51. Notice that the fee decreases when the loan decreases. So the amount that's actually being dedicated to reducing the principal will be $330.33. Take away $27.51, and that will be $302.82. So more money is being dedicated now to actually getting rid of the original loan. So then we do the previous balance, take away $302.82. So it's equal to $1,898.10. Now, theoretically, we can keep doing this again and again and again to fill in the rest of the table. However, we can use the CAS's spreadsheet function to be able to speed this up for us. So I've set up my spreadsheet to look like the table that we've seen in this handout. Now, what I'm going to do is I'm going to go and fill in the spreadsheet using formulas and various different values. So what I'm going to do is I'm going to go and write 330.33, because that's the payment amount each time. And I'm going to highlight that. This was for 8 months. So we're going to fill in fill range. And what that does is it sends all of my values like so. The interest, now that was calculated, so I'm going to write equals, and I'm going to write in 15 divided by 12 divided by 100, because it's going to be the same interest fee each time. And this time what I'm going to do is I'm going to multiply that by whatever the previous balance is. So in this case, it's E2 or 2,500. So there we go. So that's the same interest that we calculated before. In the principal reduction, as you might remember, what that means is how much of that monthly repayment is being dedicated to paying off the loan. That's going to be equal to, so I'm going to write equals. I'm going to click on B3, which was the regular payment. I'm going to minus the interest. So that's how much is being reduced each time. And then we're going to type in this balance section, equals. And then what I'm going to do is I'm going to click the previous balance, which is E2, minus the principal reduction. And there we get our final result. So you can see so now I just need to replicate these formulas in the next few rows. So I'm going to highlight, press copy, then go down a row and press paste. As you can see here, then it has gone and filled in the next one for us. And then once again. Now, when you're creating an amortization table, you want to make sure that the final value is equal to 0. So what we're going to do is we're going to look at this value here. So what we're going to do is we're going to alter the payment amount for the last one. So instead of $33.33, what we're going to do is we're going to add 2 more cents to it. So we're just going to make that 35, and you'll see it's come up with this weird E value. That's because it's trying to get very, very slow. It's for a very, very small number. So what we can do now, if I just go to the cog and go to basic format, you'll notice that it says normal 1 is the number format. I can change that to fix 2. And what that does is it turns everything to 2 decimal places. So now what I can do is essentially just copy and paste this into our table here. Example 9b.3, a business borrows $10,000 at a rate of 8% per annum. The loan is to be repaid by making 4 quarterly payments of $2,626.20. Fill in the amortization table for this loan. So we have a partially filled in amortization table, and we could set up a new one in our spreadsheet, or we can go and calculate each one as we go. So the first one to do is this interest here. So we need to calculate the interest. So it's being made as quarterly. So first of all, this is going to be 8 divided by 4. So where did I get the 8 from? That was from the 8% per annum. Where did I get the 4 from? That was the quarterly repayments. And then we're going to divide that by 100. And then times it by the previous balance in the loan, which is this one here, this 10,000. And this will tell me the fee. And as you can see here, our fee amount is $200. We can double check to see if this is correct because we want it $200 plus the principal reduction should be equal to the payment here, this 2,626. So 2426 and 2626.20 take away 2426 is equal to $200. So there is another way that we can actually go and get that $200. The next one we need to work out is this principal reduction here. So the principal reduction, remember, is the payment take away the interest. So this will be $2,626.20 take away $151.48. And that gets me $2,474.72. Now we need the balance of the loan at this point. So the balance of the loan is going to be the previous balance, take away the, in this case, it's going to be taking away the principal reduction, so that amount there. So this is going to be $5,099.08, take away $2,524.22. And that gets me $2,574.86. The last box here is then to calculate the total amount of interest. So this will be 200 plus 151.48 plus 101.98 plus 51.50. And that gets me $504.96.